Good morning to everyone. Welcome back to chemistry class. Myself Shiv Ganesh, Faculty of Chemical Sciences, the Samskar Gurukul International School. In last session, we discussed about balancing chemical equation. In today's session, we are going to learn about types of chemical reactions. Types of chemical reactions. Chemical reactions are classified into four types. They are chemical combination reaction, chemical decomposition reaction, chemical displacement reaction, and chemical double displacement reaction. Let us talk about chemical combination reaction. Chemical combination reaction. Let us see chemical combination reaction with a small activity. Take some amount of quicklime. Quicklime means calcium oxide. Here CO means quicklime. Take some amount of quicklime in a beaker, add slowly water to this. Formula of water H2O. When we add water to the quicklime, we notice there is a formation of white turbidity solution that is called Slacker-Lime. Formula of Slacker-Lime CaOH twice. CaOH twice is called Slacker-Lime or lime water. Here quicklime CaO. It is in solid state. H2O is in liquid state. And CaOH twice, calcium hydroxide or lime water, is in white turbidity or is in aqueous state. Now, this calcium hydroxide can react with atmospheric carbon dioxide slowly. Calcium hydroxide slowly react with atmospheric carbon dioxide, which forms CaCO3, calcium carbonate, and forms water. Look at first equation. Addition of water to quicklime, which forms Slacker-Lime. This is an example of chemical combination reaction because in this reaction, two substances react together to give a single substance, or two reactants react together to form single product is known as chemical combination reaction. The general formula of chemical combination reaction is A plus B is raised to AB. This is the general formula of chemical combination reaction. After formation of Slacker-Lime, this Slacker-Lime is used to paint walls. When we paint walls with the white paint, then this Slacker-Lime slowly reacts with atmospheric carbon dioxide. Then that is turns to the milky white substance that is called calcium carbonate. It is a solid state and which also gives out water molecules or moisture. So this reaction is mostly useful in white washing walls or painting. In painting industries we use this reaction. Let us consider one more example. Burning of magnesium. Burning of magnesium is another example of combination reaction. And magnesium burns in air to form magnesium oxide. The balancing equation we write here 2Mg and 2MgO. Here magnesium is a solid state which reacts with gaseous oxygen to form magnesium oxide, which is a solid state. Here two reactants combine together or react together to form a single substance is known as chemical combination reaction. And some other examples of chemical combination reaction are burning of coal, burning of natural gas, burning of coal. Let us see the equation. When coal burns in air, which release carbon dioxide and energy. In first reaction also, we notice energy liberation because when we touch the liquor, we feel hot because energy is released, energy liberated during chemical reaction. Such reactions are called exothermic reaction. It is an exothermic reaction. Exothermic reaction means during chemical reaction, energy liberated or energy released. Not only addition of water to calcium oxide, but also burning of coal or burning of magnesium carbon, which release energy. So these are also called as exothermic reaction. And respiration is another example of chemical combination reaction, because during respiration process, the food which we eat in the form of carbohydrate, which react with oxygen present in the dissolved blood, and these food particles decompose into fragments and release energy. That is called cellular respiration. The cellular respiration takes place in the body, which release energy. So energy is releasing during the process. That's why respiration is also example of exothermic reaction. These are some of the example of chemical combination reaction. Next, let us see second type of chemical reaction. Chemical decomposition reaction. Chemical decomposition reaction. Let us consider few grams of ferrous sulfate. Let us consider few grams of ferrous sulfate. Chemical formula of ferrous sulfate is FeSO4. It is a solvent state. Take few grams of ferrous sulfate in a boiling tube and heat them with the help of Bunsen burner or spirit lamp, and hold the boiling tube with a pair of tongs or tissue holder. Then the single substance or the single compound of ferrous sulfate is dissociated to form ferric oxide Fe2O3, and which release sulfur dioxide and sulfur trioxide gas. For balancing equation, we write here 2FeSO4. 2FeSO4 gives rise to Fe2O3 plus SO2 plus SO3. Let us verify whether it is balancing equation or not. 2 ferrous atoms on LHS side, 2 ferrous atoms on RHS side. Here 2 4s are 8, 8 oxygen atoms. Here 3, here 2 5, 5 plus 3, 8 oxygen atoms on both sides of the equation. Next 2 sulfur atoms. Here 1 sulfur, here 2 sulfur atoms on both sides of the equation. So it is a balanced chemical equation. So decomposition of ferrous sulfate gives ferric oxide, this is solid, sulfur dioxide gas and sulfur trioxide gas. In this reaction, one compound is decomposed to form more than one substance. Let us take one more example. Thermal decomposition of limestone. Formula of limestone CaCO3. Thermal decomposition of limestone. CaCO3 is calcium carbonate, is a solid. On heating, the CaCO3 is dissociated from CaO and CO2. CO is solid called quicklime and release carbon dioxide gas. In this reaction, calcium carbonate is decomposed to calcium oxide and carbon dioxide. And these two reactions are examples of chemical decomposition reaction. Let us take one more example. Decomposition of lead nitrate. Formula of lead nitrate PbNO3 twice. PbNO3 twice is the chemical formula of lead nitrate. Decomposition of lead nitrate. Here delta symbol indicates decomposition reaction. Delta symbol indicates heat children on heating. Decomposition of lead nitrate produce lead oxide, nitrogen dioxide and oxygen gas. For balancing equation, write 2 here. 2 PbNO3 twice is raised to 2 PbO plus 4 NO2 plus O2. Let us verify the equation. 2 Pb atoms on LHS side, 2 Pb atoms on RHS side. Next, oxygen atoms. Here 3 2s are 6. 6 into 2, 6 2s are 12. Here 2 atoms. Here 4 2s are 8. 8 plus 2 10. 10 plus 2 12. 12 oxygen atoms on RHS side. Next, nitrogen atoms. Here N2, 2 and 2. 2 2s are 4 nitrogen atoms on LHS side. On RHS side, 4 into N, 4 nitrogen atoms on RHS side. So, it's a balanced chemical equation. For doing this activity, we take few crystals of lead nitrate in a boiling tube. Hold the boiling tube with a pair of tongs. Now, heat the lead nitrate. On heating lead nitrate, we notice brown fumes. The brown fumes is called nitrogen dioxide gas. Brown fumes known as nitrogen dioxide gas and also release oxygen gas. Look at the equations. When you observe them, here one compound is decomposed to produce more than one product. Such kind of reactions are called chemical decomposition reaction. The general form of chemical decomposition reaction is AB is gives rise to A plus B. So one compound is decomposed to form more than one compound. AB is a compound which is decomposed to simpler substances. More than one simpler substances are called as chemical decomposition reaction. Next, these are called as thermal decomposition reaction, children, because decomposition reactions carried out by thermal energy. Those are called thermal decomposition reaction. Next one. Next type of decomposition reaction called photodecomposition reaction. Decomposition reaction. Let us see what is meant by photodecomposition reaction. Photodecomposition reaction means the decomposition reactions carried out in light is called as photodecomposition reaction. Let us discuss photodecomposition reaction with a small activity. Take some amount of silver chloride or silver bromide in a china dish. Put the china dish in the sunlight. Initially, the silver chloride doesn't have any color. It is a colorless substance. When you put silver chloride, which we have taken in the china dish, after some time, the substance, the silver chloride which is present in the china dish, it turns to greyish color compound. This is because silver chloride, formula silver chloride, AgCl, which dissociate to silver and release chlorine gas. 2 AgCl gives rise to 2 Ag plus Cl2. This reaction takes place in the presence of sunlight. Here HNO represents sunlight, children. Here silver chloride is a colorless or it is a white compound which turns to greyish color. Greyish color compound means which is a silver metal and release chlorine gas. Here one compound is decomposed to more than one product. So it is an example of chemical decomposition reaction. See one more example. Decomposition of silver bromide. Ac here. When you place this silver bromide in the sunlight, which also changes to silver metal and release bromine gas. But this silver bromide is in yellowish green color. It's a yellowish green color compound which turns to grey color. Grayish color. The balancing right over here, 2 AgCl gives rise to 2 Ag plus Br2. Such kind of reactions are called photodecomposition reaction because decomposition reactions carried out in sunlight called photodecomposition reaction. Next, one more kind of decomposition reaction is electrolysis of water. Electrolysis of water. Let us see what is meant by electrolysis. Electrolysis means it is a kind of decomposition reaction. This decomposition reaction carried out by electricity is called as electrolysis. This electrolysis reaction takes place in electrolytic cell. What is meant by electrolytic cell? Let us see. Electrolytic cell is a cell which is made up of metal container which contains two metal rods called electrodes. These are called electrodes. One has negative charge, another one has positive charge. Negative charge electrode is called cathode and positive electrode is called anode. So cathode has negative charge, anode has positive charge. Now this cell has to be filled with acidified water, because we are talking about electrolysis of water. So take some amount of water in the cell. This is called acidified water. Acidified water means we add few ml of acid to the water. Now connect the terminals of the battery to the electrodes. This is positive terminal as connected to the cathode, negative terminal is connected to the anode. When electricity passes through the electrodes, then electrolysis takes place. Electrolysis means decomposition of water takes place. Decomposition of water takes place. Formula of water is H2O, which is dissociated into H plus and OH minus ions. So water can dissociate into different types of ions, H plus ions and OH minus ions. H plus ions are collected at cathode because cathode has negative charge. That's why positive ions are collected at cathode. And OH minus ions are at anode because anode has positive charge. That's why opposite these other ions are liberated at anode. So different reactions takes place at different electrodes. Let us see at cathode. At a cathode, reduction takes place. Reduction takes place at cathode. Reduction means gaining of electrons. So H plus ions are liberated at cathode. H plus ions gain electrons to release H2 gas. So which gas is liberated at cathode? Hydrogen gas is liberated at cathode. Here we collect hydrogen gas. At anode, oxidation takes place. Oxidation means loss of electrons. At anode, OH minus ions are liberated. This OH minus ions transform to water, oxygen, and those electrons, 4 electrons. So at the anode, oxygen gas is liberated. So this is the electrolysis of water. Water get dissociated into hydrogen gas and oxygen gas. Hydrogen gas liberated at the cathode. At cathode, we get hydrogen gas. At anode, we get oxygen gas. This is called electrolysis of water. It is carried with the help of electricity. So these three are types of chemical decomposition reaction. One is thermal decomposition reaction, second one is photodecomposition reaction, third one electrolysis of water. These three require energy. So these are called endothermic reactions. Endothermic reactions. Endothermic reaction means require energy. Require energy. So this is today's class, children. In today's class, we discussed chemical combination reaction and chemical decomposition reaction. I hope you understand today's class. We'll meet in next session. In next session, we will discuss about chemical displacement reaction and chemical double displacement reaction. Thank you, children.